Okay, I want to look at an example problem from Chapter 4. A survey was given to 200 people who owned a certain model of car. It was found that 34 had trouble with the transmission, 46 had trouble with the electrical system, and 12 had trouble with both. Part A says to define the events and state the given information using probability notation. This is the first thing you should do on most of these problems. Ultimately, it'll help you to be able to use the formulas to solve them. So the first thing I want to do is establish what the events are. Now, if I look at that problem, there's really two things that are going on there. It's talking about people that have trouble with the transmission. And it's talking about people who have had trouble with the electrical system. Now, so that we can use the formulas, I'm going to go ahead and look at the numbers that are given in the problem and write them down using probability notation. Notice it says in the first number there, it's 200 people, and it was found that 34 had trouble with the transmission. So the probability that a person owning this car is going to have trouble with the transmission is 34 out of 200 did. So I'm going to use a relative frequency there and establish that the probability of event T is 17%, or 0.17. Then it goes on to say that 46 had trouble with the electrical system. So the probability that a person owning this model of car has trouble with the electrical system would be 46, and the group there was 200, so 46 out of 200, or 0.23, 23%. And then finally it says that 12 had trouble with both. Now, that's another event, but it's really a combination of the first two. It's the intersection of the first two. So having trouble with both is the probability that both T and E have happened or are true. And how many were in that set? Well, there was 12 out of the 200 people, so we get 6%. Now this is really how you should set up these problems, because you want to be able to use the formulas. You have to establish what the events are, and then begin to use the probability notation so that you can see what numbers go where in the formulas. So when we start to work problems, as in part B, we're ready to go. B says, what is the probability that a person who owns this model of car will have trouble with the transmission or the electrical? So probability of transmission or the electrical is the union. So the probability of T union E. Now how do I solve for that? Well, with the addition law, I know that that's going to be the probability of T plus the probability of E minus the probability of T intersect E. And then all I have to do, I've got all my given probabilities ready to go. I can just go ahead and put these values right into the formula. And the probability that a person owning this model of car will have trouble with the transmission or the electrical or both is 0.34, or 34%. Let's try C. What is the probability that the person will not have trouble with the electrical system? That's a complement. Complement law. What's the probability that they won't have trouble with the electrical system? Well, the probability that they will is 23%, so the probability they won't would be 77%. D. What is the probability that a person will not have trouble with either the transmission or the electrical? Well, that refers really back to B. The probability that they'll have trouble with either the transmission or the electrical is 34%. So the probability that they won't have trouble with either of them is the complement of the union. So that was calculated at 0.34. So the probability that they won't have trouble with either of them is 66%. E. What is the probability that the person will have trouble with the electrical system but not the transmission? Now there's no direct formula for that. I'm going to look at it from a Venn diagram approach. We have the sample space, and we have two sets in the sample space. We have the people who had trouble with the transmission, and we have people that had trouble with the electrical system. This is saying, what is the probability that the person will have trouble with the electrical but not the transmission? So really we're talking about people in this little subset here. Well, let's see. If I say the probability of E, to get that piece, subtract the probability of T intersect E. In other words, we're going to take this centerpiece out. So if we look there, right there at the intersection, the probability of all of E, subtract the intersection, will give me what I want. So the answer would be 0.23 subtract 0.06, and that would be equal to 0.17, or 17%. This is a very typical approach to a lot of these problems. You want to be able to establish what the events are. You want to set up probability notation so that you can use the formulas. And a good way to start that is to simply use the notation to and the given probabilities. And then you've got to be able to take those values and put them into the right formula. Now, I'm going to save part F. Part F is a conditional probability. I'm going to save that for another file that I'm sending you. So refer to that, see how that goes. What I'll probably do there is make a little bit of argument about what a conditional probability is, and then develop the formula, and then use it to solve this part F.